Hello everyone. We have covered lunar eclipses, and at blood red they can be pretty scary, but I dare to say that solar eclipses must have been the scariest of all if you were alive 5,000 years ago. These are some examples of what solar eclipses are, and you can imagine that they would terrify somebody who didn't understand what was happening or wasn't warned that it would happen. We will be learning about solar eclipses like you see here, and we will also be learning about annular eclipses. That's not angular and that's not annual. These are annular eclipses. If you ever watch The Hobbit or Lord of the Rings, they talk about an annulus. Annulus is Latin for ring. And you can imagine, let me move this up. If you saw this 5,000 years ago, I think that would probably terrify you. So we are going to learn about what these eclipses are and how predicting them really freed up people 4,000 years ago from the fear they had in the past. This is a Russian drawing, but it was the best one I could find, so you can learn a little Russian while you're here as well. Let me move this up. A solar eclipse, as you know, is when the moon comes between the earth and the sun. And you may say, I don't understand why it's such a big deal. The moon is so small compared to the earth and the sun. And that's why I have this drawing, because it was the best drawing I could find that could show you the relationship and the apparent diameters of the moon and the sun. So think about it this way. If my outstretched hand is the big sun and I hold it very far away from me, and I have a smaller palm and I want to cover that sun, the best thing I can do is to hold that palm very close to my eyes. And in doing so, I can cover that entire big sun by having my moon very close to my eyes. Now think of my eyes as the earth, my fist as the moon, and my big hand as the sun. If I moved this moon farther away from the earth, I would see a lot more of the sun. If I move the moon closer to the earth, much of the sunlight is blocked. In the same way, the sun is obviously much more huge than the moon, but this will show you or demonstrate a bit, and it's out of scale, but this will show you that the moon is 390 times farther away from the sun than it is from the earth. In other words, the moon is very close to the earth. In other words, the moon is right in front of our eyes, the earth. And in doing so, we can approximate and have very nearly the equivalent apparent diameter of the moon and of the sun when you are looking from ancient Mesopotamia on the earth. Okay, so this is an idea that when the moon is close, you can actually cover the sun. And in fact, when you cover the sun, you produce a dramatic shadow on parts of the earth. This is evidence of satellite photographs in 1993 going over and rotating around the earth and taking a photograph on every rotation. So there are multiple photographs here that are combined together to show the entire shadow. This shadow would be continuous if this was a geosynchronous satellite, but it was not. It was rotating around and taking a photograph as it went around with each revolution. So you can see the shadow that the eclipse leaves over the earth. In looking at this diagram, three things should be apparent to you. Number one, the easy stuff. A solar eclipse is another lineup. It's the lineup of the sun, the moon, and the earth, just in a different order. The moon is now between the sun and the earth. That's number one. Number two, oh look, we still have an umbra a shadow where no sunlight exists, and we still have a penumbra, which is a partial shadow of the moon onto the earth. That is very similar to the lunar eclipses. And with the lunar eclipses, where the moon was out here, those lunar eclipses could only happen on the full moon. In other words, when the sun shone directly on the surface of the moon that was on the Earth's side. However, in this case, this lineup requires that solar eclipses only happen on the new moon. And the new moon, in this case, means that the sun falls on the moon on the side that is away from the Earth. So that solar eclipses only happen at the new moon, but not at every new moon. And they're a lot scarier because what is eating the sun seems to come out of the blackness of the night. So they can be quite a bit scarier. We said that solar eclipses can only happen on the new moon and not at every new moon. And why not? For the same reason that lunar eclipses should happen on the full moon, but don't happen on every full moon. It is the tilt of the moon's revolution around the Earth, so that while there is a month of revolutions around the Earth, there are few times when that revolution is in the same angle as the ecliptic. Remember, the ecliptic is the Earth's revolution around the sun. When those two revolutionary orbital paths line up, there's a greater chance for an eclipse. So for the same reason, that 5-degree tilt on the revolutionary orbit of the moon really impacts that ability to schedule an eclipse. If you want to look at a different way with the ecliptic, you can look at it this way. The ecliptic is the orbital path of the Earth. It is called the ecliptic because it is related to eclipses. When this path lines up with the lunar revolution around the Earth, you will find the tendency toward scheduling eclipses in that time. We'll get into the more specifics later. Remember, the Earth's orbital plane is called the ecliptic. Now, we had looked at lunar eclipses, 3 different kinds. Penumbra lunar eclipses might move into partial lunar eclipses, might move into total lunar eclipses. With solar eclipses, no penumbra solar eclipses. The reason why? There are no penumbra solar eclipses because the Earth is too big to fit into this little narrow penumbra. So there's no penumbra solar eclipses. And number 2, the sun is so powerful that any shade or partial shade in the penumbra is completely overwhelmed by the sun. So there are no penumbra solar eclipses. Now, there are solar partial eclipses and there are solar total eclipses. Let's start with the partial eclipse. That happens when this Earth is rotating counterclockwise and moves into the umbra and notices that the sun, when they look up at it, it now has a chunk out of it. As the rotation continues, that chunk becomes bigger until the sun is gone, and then moving continuously, the sun becomes more and more bright as you move out of the umbra and back into the penumbra. So what we have seen here is a partial eclipse as the moon covers the sun and the Earth rotates into it. A total eclipse, the moon has completely apparently covered the sun in the rotation that the Earth is at for people who are looking up through the umbra. To look at this, here is the start as the moon just starts to cross over the sunlight, taking more and more of its shadow. This is the complete umbra. This is the penumbra, which is very bright. It doesn't have any of the shading that you see with a lunar eclipse. So this is a partial eclipse that involves umbra and penumbra. This takes about an hour. This takes a long time because of the fact, this doesn't take a long time. It just takes about an hour because of the fact that the moon is small. And so it cannot take up a lot of time in this movement. So when we are looking at a lunar eclipse, they are much longer because the Earth is much larger than the moon. Here it's the opposite, and these are shorter. When you get to totality and you on Earth are looking through the umbra and everything is blocked from the sun, that only lasts about maximum 7.5 minutes. And that area on the Earth that has that totality is maximum 270 kilometers in diameter, about 170 miles. So in that area, and I've been very near that area, stars appear at totality. Birds are silent. Animals start acting very strangely. Coyotes start howling. It's wild. If you are in a great place, you might be able to take a photograph of the corona. Difficult to do. The corona is very dim. This is not a total eclipse. This is a partial eclipse. This never went to total. This is a cloud here. And the total gradually moved away back in through the penumbra and out of the penumbra entirely. Third type of solar eclipse is the annular eclipse. Not angular, not annual, annular as in Latin for ring. This is an eclipse that is not a total eclipse that reveals the corona. This is an eclipse that's a bit less than total. The moon just can't cover as much as it could cover when it was so near. This moon is a little farther out in its elliptical orbit, so it is revealing a little bit more of the sun. And because it is revealing more of the sun, it is effectively overwhelming the gases of the corona. The way this works is that this annular eclipse has an umbra which doesn't quite reach the Earth. And that umbra, that shadow, doesn't quite reach the Earth because the orbit of the moon is just a bit farther out on its ellipsis. So that shadow, which just barely touches the Earth at its best in a total eclipse, now does not touch the Earth in an annular eclipse. And in fact, we'll have an annular eclipse, and I have that information for you shortly.